Continue our Kubernetes. I think we have just left with a couple of topics. So just to recap, or not recap, we'll try to ask a few basic questions just to refresh what we have learned last evening. So what are the 3 different ports which we will use in service? Anyone?
You are asking like a node port, cluster IP, load balancer?
That is service types. Okay. Yeah. I'm actually looking at the at the node port side. Yeah. So those 3 parameters which we use.
Your port range?
Yeah.
Service and target port.
Yeah. Service and a target port.
Yeah. One more.
Node port.
I don't remember.
Node port.
Node port. Okay. So node port, probably I think we know it is a port which is like assigned to the node. Now, so what is service port here? Okay. And
port number we need to mention in the
okay. Yeah.
service port.
So from the service point of view, we have 3 ports. One is node port, and the port on which then the service will be communicating. The other port is target port. So the target port is the port which, where this particular pod or container will be listening. Now, out of these 3, which one is mandatory?
Target port is mandatory. Hello, Raghu?
Yeah, I can hear you. Yeah. Okay.
Yeah, if you don't mention node port means it automatically assign when we create the service.
Right. Yeah, that is true. So is service port is mandatory?
Yeah, service port is like
out of 3, only one is mandatory.
Yeah.
So which one it will be?
Target port is mandatory, right?
Okay. Yeah. Anyone want to add to that? Okay. Now, so I'll come to this point. Now, so service types again, we have different types of service types, right? One is node port, cluster IP, and load balancer. So right now we're only discussing about node port. Okay. So this load balancer, where do we use this one?
When our cluster is in cloud.
Cloud, yeah. So in the cloud, this load balancer will be used. So so probably I'll do one thing. Let me just bring that presentation to you. So this is a picture which we were discussing. Service node port. Okay, this is target port, node port, service port. So they're all from viewpoint of service. So this is your service. This is your node port. The range is 30,000 to 32,000, and this is your service side, and this is your pod port. And here, yeah, the target port, the optional. The only which is mandatory one is service. Service port. Yeah. That is mandatory one. Okay. This is all we have already covered. Okay, let me go to the next one. The other service type, I think, it is load balancer, but let me probably discuss that little later. Anyway, today is the session which we have left, right? So before that, we just need to understand one thing. We also learned that Kubernetes, we also have on the cloud services, right? So GCP, AWS, Azure, these are the major right now 3 cloud providers in the market. As in all these cloud service providers, so we have Kubernetes available. So here, yeah, so we will be going to deploy and configure and maintain all those virtual machines. So there is one in-house, probably an API or a script is developed by these cloud providers, or either we use that script to deploy this cluster. Now, on AWS, apart from this thing, there is one more open source solutions also there that is called KOPS. So Kubernetes Operations. Now, what is the difference between this and the one which is Amazon Kubernetes services is that KOPS again it is a free stuff. So that means that this is an open source, not developed by Amazon or someone. So it's an open source component which we can deploy Kubernetes clusters using EC2 machines, using load balancer, using VPC, and EVS or S3, whatever it is needed from the kubectl point of view. So we also have Kube1 also. That is also one solution. So basically, it's a scripting kind of stuff. So it's just a script to deploy a cluster. So this is this setup. Let whether you deploy, you configure, you maintain the virtual machines, or use a script. This is a self-hosted model on AWS. So have you ever worked on this kind of models, or we call it like turkey solutions? Okay, not heard about it, COPS, right? Well, I'll show you that one. COPS. I think I also have a documentation. Kubernetes cluster. Okay, I think this one. So source is internet again, official Kubernetes site. On you can go ahead and find out this detail. Wherein what we have to do is you take any Ubuntu machine. The machine again you can spin it up using EC2 only. So take that mesh, or you can also go with Amazon machine also. So you need to, of course, you need to configure your AWS CLI there, so that this particular machine can talk to all the services with all full admin access you have to provide. For example, the policies I'm talking about from the Amazon point of view, IAM point of view. Also, you need to create one S3 bucket. Yeah, so S3 bucket where it can store the cluster information. Now on this machine, you just need to install kubectl. So you just need to install a kubectl, provide executable permissions, etc. So once that is done, so then you probably can go ahead and install KOPS. This is open source GitHub community from Kubernetes. You can download this stuff. And because Kubernetes require one DNS. This is optional again. If you want, you can set up one Route 53 domain. From privacy point of view, because Route 53 is not free of cost, so there is an option where you can exclude that also. But otherwise, you can go for one internal. The charges are very minimal, 26 rupees. It will something it will they charge. And then you need to create one S3 bucket, because anyway you have created one that particular Ubuntu machine with AWS CLI full access. No, you can directly use the command AWS S3 make bucket and one bucket. And this environment you have to set up the expose the environment, and you just need to have one SSH keys available on this machine to be created. So you can just create one SSH keyjet. So then once you have this prerequisites, so you can start set up the Kubernetes cluster. So this is a command. So because kops anyway install, no? So you can go ahead and install. DNS private here. It is that in case if you are going for a DNS stuff, or you can use this local this thing also. If you don't want DNS stuff, without DNS you can go ahead and create this thing. So yeah, once this is created on S3, the configuration will be stored. So you can go ahead and edit that cluster, kops, edit the cluster. Wherein if you want, you can modify, let's say T233 micro, which machine you want to modify and all that stuff. You can do that particular stuff once the cluster, everything is created. So then, anyway, so now you can go ahead and create the cluster, the one which was created. In this case, it was create local. We just need to do this stuff. So -s. So if you want to review what all things going to happen when this command would be run, so without -s option, try to execute it, because when you use -s option, so what it will do, it will basically display the action it is going to perform without actually doing it. Simulation, dry run, I would say. Without an -s. So if you put -s option, yeah. So all this stuff will be triggered. So it will take some, how much time? I don't know, some 6 minutes, 10 minutes it will take. What it will do, it will spin up a master. It will, based on the configuration. Again, this configuration you can review. What master you need, what is the micro, all the stuff it is needed, everything. It will create a VPC, by the way. It will create a load balancer. It will create NAT rules. It will do everything for you. So once it is done from that machine, it is like outside of your Kubernetes cluster. So when I say what do you mean by outside? Ubuntu is not part of any cluster. No, it is just that machine. Instead of Ubuntu, you can also use any on-prem machine also. That is fine. So it is not part of any cluster and all this thing. And then you can see a master or nodes, 2, 3 nodes based on the configuration you do this thing. Now, this is a production grade setup. This kops. It is not it is not a POC, by the way. Now, what is the advantage of this thing is that you are not using Amazon Kubernetes services, which is again there's a commercially involved using their services. So you're using this Turkey based or script based installation. So what are the things is you are going to charge to your account is that only for the VM utilizations, only for that LB utilization or storage utilization only it will be charged, which is comparatively very less, like now $1 versus rupee price. Just giving you an idea what is the advantage to use these things. So most of the clients, customers, they use these things. Anyway, you get the advantage of cloud, high availability, and fault tolerance, and that anyway you are getting because your master and all these things anyway lying on the cloud regions and available zones. So that's what. Yeah, you can search for it also. So I'm not going to demonstrate on this thing. If you want to directly go for kops, Ops Kubernetes. This official documentation is available. You can follow this link. I'll give you this link too. Teacher. Same, that's another thing. But in Azure, it is right now not supported by Azure. It is actually they're working on, but in Azure, Microsoft looks like they are not in favor of this. When because I was trying to check it out, but in Azure it was not supporting. It's only AWS that is supporting. So AWS is very generous. Azure looks like a little commercial in this, allowing this stuff. Any questions on this, Cops? Questions? Okay. You can speak anyway. Today's the last session. So that is one thing. So cost-wise, you'll get comparatively very less. So you can go for an at least non-fraud. At least you can try this thing. Now the other one is hosted solutions. This is completely managed by the cloud service providers. So we call it as CaaS, Kubernetes as a service. So wherein cloud providers provisions and maintain those machines or what EC2 machines or virtual machines, they will install Kubernetes on it. For example, GKE and GACP, like Kubernetes engine, Google Kubernetes engine. When I think 2016, 17, when I was working with one of the client, everybody was like in the market. There is a myth that we have to use GKE and GCP because Kubernetes is from Google. Probably they is tightly integrated and then performance will be really good. Most of the client actually explored it, but later it was identified that no, it is not that because it is from Google, but yeah, even Azure Kubernetes services, Amazon Kubernetes services is also really good. So I think Microsoft Azure invested a little heavily on this Kubernetes services because 2.5 years ago, I was attending one event. So I saw that Microsoft is really doing good on this Kubernetes services Azure comparatively with Amazon. They have, I think, little edge on that, but not sure if Amazon is also picked up in this area later. So for hosted solutions, what are the prerequisites? Yeah, of course, let's say if it is for Google Kubernetes Engine, you need GKE. And then for Amazon Elastic Kubernetes Services, EKS, yeah, you need again same account, install, IAM role, VPC, etc., etc. Documentation is available. Go to that. For Azure, yeah, again you need one Azure free tier account, etc. Just we'll try to quickly review fraud gains and virtual machines. Okay. So we have discussed about an Oracle VirtualBox and then background. And yeah, these are the different images wherein you can download some virtual machines. And this is about the KubeIDM installation, on-prem installation. So I think one of the main thing, if you ever install Kubernetes on an on-prem, so and then yeah, so we'll link to the background file in case if you are looking for what do you call want to practice in the Kubernetes on the background. If you're new to VirtualBox and more, so probably this link will help you. I'll share this link with you otherwise. Kubernetes setup, KubeADM, yes, of course. You need to have a port network to be created first. Like you have to join the node to the cluster, and the master you have to initialize and KubeADM install Docker and master. So these are the other things which you need to do on the worker side. Okay, so this one, before we go to this level, in case certifications, I guess you already know about certifications, Kubernetes certifications. Sticky. $300. I think we already mentioned that thing, right? So they are changing, I guess, right? In the month of May or June, I heard some news about this. The increasing the fees or something like that. So yes, if you are looking for certification, yeah, go for a CKA program. So and then so CKAD is also there. You can go for that. And both are CKEs were like mostly what do you call? They talk about administration level, and AD for like deployment and all this thing. It is not that CKED is for developers and all this thing, but yeah, both are really good in case if you want to upskill yourself. Yeah, so this is the weightage, I guess, in CKE architecture, workloads, and storage troubleshooting point of view. You can go through this thing. This is all thing you can take it from home. I think what is the thing. So they'll be having a video, and you have to take the exam, proprietary exams, I guess we call it as. So how many questions? 2 hours. Yeah. So all scenario based. So the online exam consists of set of performance based items, problems to be solved in a command line, and yeah, 2 hours for this CK. Which is about CKE, and the other one, I think the pass percentage is 75% for CKE, I guess. So CKAD, this is 66% pass percent mark. So application developer program, again from CNCF only. So this is one more certification. So this is helps the users to design, build, configure some cloud native applications for Kubernetes. It is not again so not only for operations guy, but developers, anybody can take. So which talks about more about application development and deployment type on this Kubernetes, this stuff, this course. So which will give you good knowledge. So I think post this thing you'll be able to good in OCA and complaint runtime and all these things. And yeah, this is all. And spend some time. This is the core concepts where they will be covering. Out of these two exams, CKAD is comparatively easy because 66% is this things. But otherwise, both exams are good one. It's only that it's because the problem solving. So like we did yesterday one code cloud, no? So you will be having that scenario machines will be given to you and the problem will be given to you. For example, they say that this particular replication controller is not coming up. Can you please fix this? So that's a question. So on your machine, you need to find out, first of all, is it a YAML definition file is issue or not? Or is it a syntax issue? Or is it a port issue, etc.? You need to fix that. Anyone already certified or taking going for the certification? No. Okay. One, I think in the current clients in the requirement, it is good that you should take at least 1 or 2 account certifications, right? It will help you. So is it that reimbursement option is available with you, your company?
Don't know, Raghu. We need to check it.
Ah, I see. So that is all from the Kubernetes point of view, but I think I have a couple of slides. Let me just check it out. The certification, anyway, we just now discussed, right? I think I put some points here. To take certifications. Of course, Docker anyway, you know, Kubernetes also know you have good knowledge. So the basics of Kubernetes is required as a prerequisite. YAML, basic language, setting up basic lab environment that you should know. So, and then the objectives is that core concept scheduling, logging, monitoring. And ALM, application lifecycle management, cluster maintenance, and the security point of view. And then storage, persistence, networking, installing and validation, troubleshooting. So you can go ahead and use this code cloud as a practice test, or you can set up your own on-prem setup as well. And then syntax in YAML, so that is needed practice purposes, because even if you look at it, I was when we started initially, it was trying. It's been like 3-4 months, not just taken a session, so I lost that particular practice, particularly Kubernetes side. Coming to CKE, yes, $300 exam fee with 1 free attempt. That means you can successfully fail 1 exam, and there will be no additional cost. Yeah. So what do you call a proprietary based, right? Online, someone will watching you. It's not MCQ. So scenario based. For CKE, I think 3 hours. Okay. Check it out, that website. It was saying 2 hours. Probably we'll go with website. Consists of 24 problems. Yeah, this is, we already referred. Exam curriculum is available, official one. CNCP curriculum, you can go here. Candidate handbook is there. And this is the exam tips before you going further. I think if you use this one, you'll get 15% discount. Oh, wow. So you can use this DevOps 1.5. Okay, cluster IP. So I think this one we will try to discuss. So we have seen load balancer. We have seen node code, right? Cluster IP is something which we are not discussed now. So take an example wherein we have 3 layers: web app, and let's say cache layers. And here we have 3 bots because of the user requirement. We have 3 bots we have configured here. Now we also have an application layer. Let's say that here it is Apache running, here it is Tomcat running, here let's say Redis cache running. So when you hit an application, most application will be lying in the app layer. Okay, so your web will be routing the request to the app layer. And cache layer is there before, I think, database. The database anyway, it will mostly clients will not host on the containers. It is on-prem or cloud. So the cache is just to improvise the database performances. So it caches database stuff. So then the question is, if I try to set up this one-to-one connection, the problem will be, what if any of this bot dies? So to address that issue, you need to have a kind of a cluster or a load balancer stuff. So my pod will talk to this particular component, and this component will take care of health status of these pods based on the availability, based on the load, based on the user base. It will distribute the traffic to the respective pods. And then from there again, the same stuff. So you have Redis, what we call LB, we can call it as RA, component or load balancer. My pod, front end pod will communicate to this stuff, and this will go to this particular stuff. So how do you define this kind of stuff using Kubernetes services? Let's take an example. If this is our service definition file, yeah, API version v1, kind is services, metadata, the name we given is like backend. So if we'll refer the previous one, this is what we are trying to create, the previous slide. Okay, so the backend we created. And coming to the specification, that is a fourth category. Yeah, we need to define that now. So this is cluster IP now. The service type is cluster IP type, not a load balancer one, not a that node port one. Here, yeah, ports, target port. Then the backend is exposed, like on which port is it? That is the target port 80 here. And here where the service is exposed, 80. So these two things we need to define. And in your environment, you probably might be having n number of ports, but I don't need all those ports to be connected by my backend service, right? So I'll be filtering it off the ports which are having this name. In this case, selector is okay, wherever there is a label called my app, and then wherever the type is like backend. So copy it from the label section, where in the pod the definition it will be created mostly. You just need to filter it out. So it will group them, and then it will be mapped to this particular service. Once the file is ready, so kubectl create -f service definition YAML. You just go ahead and create, and then get services. So service can be accessed by other pods using this cluster IP now. So now look at this section. So we have our own, let's say, native load balancer, F5 kind of stuff. 1, 2, 3, 4, 4 nodes. Yeah, physical nodes available. In each node, 111 pod is running, and this each node having a separate IP. This is 2, 3, 4, 5. So if this DNS, when it is hitting, it will talk to this load balancer. Load balancer will try to equally distribute the traffic to the respective nodes. Now, in this case, if it is on-prem, how do we use this thing? Or if it is this thing, yeah, you have to talk to the VM guys and then integrate that FI components and everything with this particular stuff. It's a tedious process. So mostly clients will be using that IP address and all this stuff. The private cloud, we call it as. In case if it is cloud, GCP, AWS, Azure, as of now, this load balancer is supporting only these 3 cloud providers, wherein you can just define this type called load balancer. Service will be the same. Now automatically, what will happen that Kubernetes, whenever we try to deploy this way, it will spin it up a load balancer in the respective cloud service provider, and it will configure this particular target port. Target port is what? Your pod port, basically, and the service port. So where it is listening or this load balancer. So in the case of load balancer section, yeah, you also have node existence, right? So the node physical nodes or virtual machine or EC2 machine. So that port is also has to be mentioned. So we will take this project right now. We will try to execute. I'll see time permits. We'll try to complete this one. So what is the requirement is in Docker, where is one sample voting application is available in the Docker. So there, so what that is that there is one image called voting app, which is developed in Python. There is one more um, uh, resulting image available developed in Node.js. And you have one database PostgreSQL. You have a Redis cache stuff. This is developed in .NET. Separate images there. So what it is voting is, it is actually asking us to vote whether you are going to go on, want to go with cats or dogs. Once it is voted, this will be received by .NET with the help of Redis. It will be stored in DB, and our result app, which is like developed in Node.js, will fetch these details and then display that in the dashboard. This is the workflow. So all these components are developed in different languages. Microservice based definition, what it is trying to tell us, it is immaterial whether in which language it is developed, on which platform it is developed. As long as it is available in an image, it is isolated and you can deploy on the same machine. So if you want to do this stuff using Docker, can I do that? Yes, you can also do this stuff. So for example, you have to run this Redis first from Redis image. You have to run this database by giving a name from Postgres. You have to run one more container using this image called voting app. So while doing that, you have to link this with your Redis. Why? Because database, voting app, this voting app has to have a link with Redis. So we're following the same stuff. So now then later when you try to do a DB deployment, it has to link with, result app, it has to link with database. So result app has to be linked with database. And then worker. This is has to link with both Redis and database. So that is the reason it said link DB, link Redis. Okay. So I think you might be knowing these things. The linking option is deprecated in Docker and may support withdraw support in the future editions. So if I do if I want to deploy the same application in Kubernetes, so let's see how do we do that, and then we'll try to deploy. Very high level, what we need to do? We need to deploy containers. We need to enable connectivity, and we have to expose this to external access. That's the only things. So step one, you need to deploy pods. So connectivity of pods is also needed. So for example, Redis, this is a port number. Need connectivity of voting to a worker pod. Postgres need connectivity to result app. So this is input one, and this is the output one. And voting and result app need external access on port 80. Yes, of course, because outside they have the accesses. Node port is needed. And worker is not accessing any by any app. Yeah, that's true. And you also have to create a cluster because if you remember that worker service for worker So you, even though they don't require a node port that expose, cluster IP is needed because it has to talk to both worker and database as well. So a service for worker is also needed. So again, node port not needed here. So voting and results, we can use node port because yes, that is the final hitting page, results page. No? So it has to be accessed by the end user. So you need that particular stuff. Total how many ports? 1, 2, 3, 4, 5. 5 ports. Voting, results, Redis, database, and the worker. 5. And how many services? Okay, 4 services. So 2 cluster IP and 2 node ports because voting and results required this thing. Voting and results is required 2 services, and this worker required both Redis and database services. So 4 services needed. One is two are node ports, 2 are cluster IPs. So all images available in Docker Hub. So this is the repository, Docker samples example voting app. So let's try this thing. So let me log into my AWS console. What happened, like, I forgot to switch off T3 machine. In the midnight, I realized that no, I did not forget the minute I forgot to switch off. Let's say, I think I don't how much I'm getting for this thing, my billing dashboard. Actually, not more than 100 rupees or 50 rupees. Okay. This is 13 rupees. It was yesterday's also considered. Yeah, it is very limited. See, we spent about around 4 p.m. and I switched off at around 12 a.m. It's almost like for 8 hours it was running. Yeah, so not sure if it is considered yesterday's also. So what I meant to say that now that is fine. You still can go ahead and use these services for learning purposes. Charges are very minimal. Anyway, you're not going to office to have a coffee now, so you can use that money here. The total, like, how many applications are there in your environment? Like, is everyone from the same team or from different teams?
Different teams. So across the org, we are attending this.
Oh, is it? Okay. So that's the reason I see people are quite. Nice, like, one of the quite match I have taken in the recent class. Is it DC or Ubuntu? Ubuntu, I guess. Right? I forgot. So do we have some space here? /dev size is 12 GB. Okay, available project. That is more than enough. I remember I also uploaded to GitHub, but not sure if it is. they uploaded or not. Kubernetes. No, looks like it is not there. This is Kubernetes. This is different one, I guess. Anyway, I'll follow the presentations for now. I think we also have those Visual Code Studio codes available. Created a separate folder, voting app. Let me try to open that. Yeah, it is already open. We can find YAML files directly. Then, how do you link this with GitHub? Anyone knows? Visual Code. No. Okay. That's fine. So let's go to the presentation. First one is coding app in MiniCube cluster. So create a pod definition, coding app pod that YAML. By the way, is MiniCube started. Okay, by the way, someone yesterday had an issue, right? MiniCube. So was that fixed? Yeah, I think of Docker installation and Ubuntu.
Yeah, so in the VM it wasn't fixed. Daemon was not running actually.
Was it? Okay. So then what did you
Docker
do?
daemon. I'm trying in an EC2 machine. Ubuntu.
D3 micro. Yeah, good. Yeah. I think there are minimal charges. If you just switch off like within 2-3 hours, so that is also will be waived off.
Okay.
Kubectl. Let me clear all existing pods and all this stuff. So we have, let me see what are things. Kubectl get all. Okay, so let me start with replica sets. Kubectl get rs. Delete. Run and delete. And then this one, this is as part of deployment. Probably get deployments. Kubectl delete deployment content. Right. And my Nginx. My Nginx. So I'm just cleaning all this. So record sets gone. What else we have? Services are there. So one is Kubernetes and this thing that anyway by default will be there. My app. Okay, so kubectl delete this service. My Nginx. Then my service. My app services. And then my app service one. Here almost all of the pods are there. Delay. Apache, MiniCube, Nginx, Redis. Let it be in MiniCube and try to be Nginx, Redis. So our cluster is clean. So now everything is gone. So first, let me create a voting. Go to so we will try to start with one pod. Sequence important now. So first pod is voting app pod. So is it available in voting app pod in my project? Voting app pod, yes. So just review that AP version V1, Kinase pod, metadata. So name of the pod, voting app pod. So there are two labels given. One is voting app pod and then also demo. And then specification containers it is going to create is voting app. And where is the image? It is there in that particular repository, Docker samples, example voting app underscore. Now coming to the ports, container port 80, that's it. That is the only one we are defining here. Get done. So create a port definition. And then result app port. Okay, so it is trying to do all this one by one. Where is my result app port? This one. So same port, the same just result app port name is the name changed. Otherwise, in the label, this is the one which we given, and this is common because in case if I want to select both these ports, I would like to use this application name demo voting app as a label. The label, the number of more labels you have, the flexibility you'll be having to select the ports based on the syntax. Okay, so label. So container name is result app. All this stuff. And what else we have? We have total 1, 2, 3, 4, 5 parts. No, 2 we are done. Now Redis pod we need. This is my Redis pod. We know Redis pod is in some 639C. Yeah. So the container name is Redis only. Image is Redis. This is not required to download from Docker samples. Redis is available in Docker Hub. And the container port is 639. We're just exposing, that's it. And the fifth pod, I think this is the last one. Do we have any other pod? So database we are trying to set it up. Postgres. Postgres hyphen pod.yam. Metadata Postgres pod, label Postgres pod, demoting a container name is this thing, and which port this Postgres is using 5432, and the environment Postgres user. Okay, I think this value, the code is not properly. So this also has to be modified. Yes. The total 1, 2, 3, 4. Okay, we have one more pod. Total 5 pods we created. Okay. And how many services? 4 services, right? One is Redis services because Redis has to talk to the worker. So Redis service. This service. Yeah. So here we are using service here, Redis service. So port we are saying 6397, that is Redis. Target port is 6397. Yeah. And the name of the selector which it has to use is Redis pod. Application name demo voting app. That means so selector it will try to select the Redis pod, also the label name demo voting app there. So, so Redis pod anyway we given, right? So this one Redis pod we given. Yeah. Other one is Postgres. Is it available in the user code also? Postgres service. Postgres 5432. That's a port number. So this service also created, and also one more, two more services. Right? One is voting app services, which has to talk to the Redis. The service is needed. We created another service by name voting service and app demo voting app. This time it is node port. So inside the node port, again, we have to supply 3 different ports now. One is the port node target port, that is pod port. Node port is 30,004. I hope 30,004 is free. And we'll take it out in case if these things are not moving. And about this is result services. By the way, result to what? Result app service. Yes. So this is also services also done. What else it is pending? Services get done. So total 5 pods, 1, 2, 3, 4, 5 pods, and 4 services we created. So 1, 2 services, 3 services, 4 services. Yes, one is Postgres service, one is Redis service, one is result app, one is voting app. Voting app has to talk to the Redis. Result has to talk to the Postgres. So 2 sides you have to connectivity. Also, Redis has to talk to worker, and Postgres also has to talk to worker where the storage is needed. So get SPC, same. Just to check it out if there is any. SPC is fine. So let's start with coding pod. So here. Then keep cutter create voting app pod. Hyphen, yeah. Earlier is also same, but what happened? There must be spare pod created. Voting app pod is created. Let's close this one. And then service for that associated service for voting app service. Okay. Just confirm is what it is saying. Create pods. Get SVC. So service Kubernetes voting services created as well as pods also got created to pods. So MiniCube service voting service URL. You must specify service name. The service name is there, right? You pattern. It is not service, but it is SPC. Okay. Service. App service. Okay. No shortcut flag. You and your what was the service name? You get SVC. It's not that. Just a service. Right. So we got a URL. So you can check it out also, by the way. So 30,004. So take this and the 30,004. Yeah. So your voting application is now live. So we can also see and which pod it is listening. Let's say cat. Okay, we did not completed the remaining part. Also, that is only that that is helping that it is showing the application there. Now go ahead and create the remaining one. Create. That is done. And Redis service. Service is done. Now check it out. Get all SVCs. So three Redis forwarding board services, Kubernetes Redis voting services. And voting services anyway, that is node port type. It is only that Kubernetes Redis is a cluster based. That is how we have mentioned that. Next. Then Postgres pod. Postgres pod. Also creates services. Postgres we done, and your service also done. Now next one is worker app. Worker pod, and then worker service. Worker, no, worker service, I think not written now. Because worker is anyway not connecting thing. It is that Redis and then both are connecting. And then result is needed. That is the final results. The result icon pod. Result app. Resulting. And then result service. So finally, we deployed all this. So this is what we have done. So deployments we did 4. Pods we did voting, result, Redis, DB, worker, and services. We have done 1, 2, 3, 4. Okay, so this is how we have designed everything. So now let's just check it out, the access stuff. So just go to the stuff first. Where do you check it out? You check it out, get all. We have seen one error in worker pod. Okay, let me check it out. Kubectl describe pod worker dot pod. Design it, full access denied. Okay. So the image which was used in the worker pod looks like is not working. So just check it out, worker pod. So code cloud example voting app worker. So let's go to the Docker Hub. Docker.com, and what was the repository name? We use code cloud, but I think we used for Postgres and Redis we use the same thing, and then for OT it is Docker samples. Now go to the worker, try to update this. I don't mention any version because if I remove the version, I get the latest one. So because we did some changes, if I do pods, so I can delete the pod now. Kubectl delete pod worker -pod got deleted. And try to deploy the pod once again. Yeah, so looks like now it is working. Yeah, this. So now get all just to see if everything is up to 6. So now input is 3004, output is 3005. I mean, not output app. Let's say you quoted some cat, it should capture. Take it out in the output string. Yeah, so this is where the application is downloading. So you are connected and then we are getting the results. And change your host. But this is application stuff. So we are right now connected and then we deployed it. So that's all from my end. I'll give you one feedback link so you can just update that. Have you received my feedback link, which I've shared in the meeting chat?
Yeah, this is.
Okay. So yeah, I'll give you like a couple of minutes if you want. I can just complete that. Meanwhile, yeah, feel free to ask me any questions, any suggestions, anything from anyone.
Raghu, can you please explain the first task, at least with the flow diagram?
Okay, 1 second. Let me launch that. Start my project. So I'm doing a screen share. So you can develop a role in Ansible to create tutor attached with AWS load balancer using Amazon Linux. One web app, one Tomcat machine with health string to set up web and sample application with reverse proxy. So the role should accept arguments with number of each machines we create in the version. Okay. Let me put this in the diagram. So in AWS, we need one FI. I mean load balancer. One load balancer. And you also have to have one EC2 machine and two EC2 machines. This is for okay. It's saying that only one LP for now. one in. So there should be an else string. You need to configure else string for this web server. Web server, and this should contact one more EC2 machine, which is your backend app server. Now we need to install what is the web, and then we need to install JDK inside that. So you can go ahead and install, of course, Apache here. Apache. So you also need to install app here. Probably you can install Tomcat. And you also need to, by the way, JDK has to be installed now. Yes, JDK has to be installed. So JDK has to be installed. Now, so total how many playbooks you need to create? Or of course, this is a role we said, right? So role you have to create. So how many roles we have to create? One role is for load balancer. Okay, let me put a number otherwise. This is one load balancer. And then you need to create one more role for Apache, one more role for application. This and this, I think, you take a call. If you want to know, you can put both this thing, 4 and 5. I'm okay with that. So do whatever you'd like to do there. And from the provisioning point of view, load balancer, yeah, you need one more role. 6. From here, EC2 point of view, you need to provision one machine, right? 7. This, what you can do, you can have one EC2 role wherein you can, it should accept the arguments that, okay, I need 2 machines. So T2 micro and all these things, so you can refer. So that is fine. So there's a total like close to 7 roles you need to create. Number is not fixed. You decide flexible. The more number of roles you have, the more facility you'll be having. Now, finally, what you need to do, you need to create a wrapper role. Wherein you will be calling all these roles. So, for example, host. Don't follow the syntax, but just and then calling all this roles like role 1, role 2. Likewise, you'll be calling, and then wherever there is argument is needed, you will be supplying arguments. No? So that check it out how to supply the arguments, and then all these things. So this is what you need to do. So this roles, you need to upload, send it by compressing. And once that an entire everything is created, so like load balance and all these things, so take a screenshot and put it in a Word document along with this thing and send it out. So this is your one assignment. Any questions on this? So total marks will be 100. So this is 50 marks. Right? 50 marks question. And the second one, This is a very extremely simple one. No questions right here. Okay. So second one is Jenkins one. So just need to create a Jenkins repository. So take a Jenkins repository and have your Jenkins machine is ready. So while pulling the code, you'll be having a Maven, right? So this Maven, what do you do? I don't want this to be configured in Jenkins, but you need to call. I mean, a Maven image has to be there. Okay, so for that Maven image, you need to refer. So using that Maven image, create a WAR file, and that WAR file you need to supply and as a what do you call argument a parameter and create a separate image. So this is your Maven image, and this is your app image, which is like WAR file will be created now. So this is your WAR file. Now, once this image is ready, anyway, it will be stored in the repository now. It has to be deployed in a Docker swamp. So we'll be having one, what do you call leader, right? Leader. And then one node you'll be having. So together we go, it's enough, like for example, Docker swamp mode. This is enough for us, Docker swamp. One is leader, one is worker. So you need to deploy to this here. So what you need anyway for you need to maintain one repository, no? Anyway for Docker swamp. So use that repositories to store these images. Repository for repository, and there anyway you have to create an image repository, right? So use that repository, store this Maven image and app images. So if you want, you can what do you call pull this Maven image from there, and then this app also. Try to store there. So that is a simple exercise. One more exercise. This is again 50 marks. So you need to take a snapshot and then you need to supply me these codes like Maven image code, app image code. That image code you need to, I mean Docker file, probably Docker file you need to, here Docker stack is also needed. So you just need to create, you need to share those Docker files, Docker image by compressing it. And once you deploy, just give me a snapshot of Docker node ls, Docker service ls, that an application is deployed. Put that in the Word document. Is this fine?
So in this case, we do not need to use Maven build thing.
Correct. Yeah. So
Okay.
yeah. So I'll give you one link, not link, one hint. Docker file. Maven Docker. This one. So this I have written for Maven image. So what it is doing, I mean, you can also research Google, you'll get it, but you'll not get exactly one. You need to customize according to your system. So, but I'm just giving you one overview. So this is your Docker file Ubuntu I've used, wherein two variables I've created Maven version. The upgrade, you need to update this thing anyway. So what it is I'm trying to do is here I'm trying to install JDK inside this container, everything, and then also install wget, etc. And then I know where my Maven resides. So this is my download Maven Apache URL. So this environment variable, I used it so that if I don't get the latest edition, the old edition, I'll refer the latest edition. So this Maven edition is a variable, no? So this is referred. The path will be the direct one. So for example, if you go like download Maven for Windows or Linux, anything is fine for that. The official repository. You go here, download section. So this is your binary file or tar file, right? This one, copy link address, right? So this link. So from here directly you can wget your Linux machine. Wget a binary tarball. Anyway, given this thing, right? And then after that, extract this thing to where /opt. So then, why don't you move this file to opt maven? Okay, and because anyway you are extracted already. So so this is stuff, and then create a soft link. This is your soft link. Why do we are creating soft link inside the container? Because if I use Maven clean package now, it will automatically work. And then yeah. So and now the setup the Maven home directory is opt maven, etc. So this is your Maven image is ready. Once it is ready, you just need to do what? You need to build this image. So let the build is available. Image is available. So that you need to manually keep it in a repository. So once this is done, when we creating Jenkins, right? So you will use Docker run. This one's the name. What is the name? Image name Maven. Docker run Maven, etc. So it should accept the arguments. No? So it will accept the arguments. So for example, I don't know. Yeah. Okay, this is the Tomcat stuff, the war file stuff. So somewhere you can just refer that, manually try that. So to execute the image and send this particular format XML. So wherever the format XML is there, you need to run that particular image. So it will refer the form because you're using Maven clean package command, no? And build the war file. That's it. Sample code you can take anyone. I took hello world, you can take anyone. So war file will be deployed under target. Here in this case, here it is created. First manually try. So try to install Docker on same Jenkins machine. So it will be easy for you. Have an image.
Okay.
Any questions? So not only from today's topic, yeah. Any other questions from any topic which we covered in the last 3-4 weeks? I don't know how many. Okay, so Sunday by Sunday try to submit because by evening, I'll be reviewing and then we'll share the details. Hope all of you got a chance to share the feedback as well.
Yes, Raghu, done.
Okay. No questions? From the project and assignments. Okay, I'll also try to share those pictures which are just not drawn. I mean, these are just to use it as like a referral, but because it's not exactly the diagram, right?
Yes, Raghu, if we'll do and if we stuck, then it might help.
Right.
Because we can't contact you after this. So.
No, I think so you can, you can send out an email. Probably, I think I'm okay to share my email address. If any questions on projects, assignments, you can send out an email, or Lakshmi is also there. She also will help.
Okay. Any other useful, if documents are there, then please share those as well.
Yeah, sure, definitely.
Okay.
So ask any questions if you have. Yeah. Any I think any no questions? So I'll give this next like now in 10-15 minutes back to you then. So happy learning, and so you can keep in touch. I've shared my email address. If there is any questions on the project related and all those things, or any subject related, feel free to ask me questions. Whenever I have some time, I'll respond to you.
Okay. Yes. Okay.
Yeah. Thank you all. Thank you very much for joining and listening patiently, because teaching is easy, listening is very tough.
Thanks a lot, actually, so for your valuable time as well. And the training was really well. And yes, we got to know a lot of things here in DevOps, the architecture especially. So it is clear now, but the implementation is remaining. So if I'll start somewhere, I'll surely ping you.
Yeah, thanks, Manny, for the comments and feedback. Yeah, definitely. You can ping me. I'll
Okay.
try to be available and try to help you.
Okay, thank you.
Yeah, fine then. So we'll touch base again in the future. And until then, all the best. Have a what do you call us? Happy learning, and then stay safe. This has become like a very common word nowadays.
Yeah, stay safe.
Thank you. All the best. Happy weekend as well.
Okay, thank you.
Happy weekend.